So, and yeah, we kind of did actually write these in order, but we're going to do it a different way this time. This time, we're going to write our data as a frequency distribution chart. So think of it this way. I'm going to say X, this is our age, and then F for the frequency, so how many times it occurs. And we're just going to write this up. So remember the first age in order is 16, then we had 18, then we had 19, 20, what else do we have? 21, 22, we had 24, 25, 52. Oops, need more space here. Okay, and yeah, 68. Now, 16 occurred only once, so we put 1 under the F. And 18 occurred twice, so we put 2 there. 19 occurred twice. 20 occurred 3 times, remember that was our mode. 21 occurred twice. 22 occurred twice. 24 occurred once. 25 occurred once. 26 occurred once. And 68 occurred once. Now, this other thing I like to do is I like to put case. Just kind of helps me keep track of our cases. So we have 1 here in the 16. So this is our first case. 18, we have 2 of them. So this is our cases 2 through 3. And this only works again if you order them, from lowest to highest. And 19, we have 2 cases, so we say 4 to 5. 20, we have 3 cases, so we say 6 to the 8th case, so 6, 7, 8, those 3 cases there. 21, we have 9 to the 10th case. And for 22, that's our 11th to the 12th case. And then all these other ones have 1, so we just say 13, 14, 15, 16. And what you'll notice is if you progressively went in order from down, you'd say 1, so 1, 1 plus 2, 3. It'd always be your last number. So you'll know in your categories there. But the other thing we need to do here is use the rest of that formula. Now that formula says MC, just put it here again, MC is 0.5 n plus 1. And what was our n? It was 16, right? Yeah. So this equals 0.5, 17. And what is 0.5 times 17? Should be 8.5. Hope we got the same thing. But we're not done yet. So we still have to do that third step. Remember what the third step is? Determine the middle case. Okay, so what is the 8.5 case? Well, this is good, and this is a reason I used an even number of cases. If they were uneven, we would have immediately found out what the middle case was. But because it's uneven, we get an 8.5. Normally you just get 8. And if it was 8, you'd go here to this one and say, okay, 8 is in this category, it's 20. But we have 8.5. So what that means is we actually need to take the 8th case and the 9th case. Okay? And we know what the 8th case is, it's 20. And we know the 9th case is 21. And we actually have to take the average of those. So we just add them together, which is 41, and divide by 2. And what do we get? 20.5, right? So 20.5 is actually the median. So what we're going to end up saying for this data, just going to write it here. For this data, the median is 20.5 years. Interesting. So if we look up and we say, okay, we've calculated the median, we've calculated the mode. And the median, if we look at our little chart here that we use for the mode, we said 20.5. Now what was right here, 20.5? Now I want us to quickly go up and look at the mode. Okay. What did we say the mode was? 18, oh no, that was percentage. We said it was 20 years, the mode. So the mode's going to be somewhere around here, 20. By the way, our lowest age was 16, and our oldest age was 68. Oops. So we're just going to quickly write that up here. So our oldest age was 68. So 16 to 68, right in the median number is 20.5, and the mode was 20. So you notice the mode is less than the median by a little bit. So what would have been more accurate? Hard to say sometimes. Now remember, our third measure of central tendency is the mean. And the mean is very important. What is the mean? Well, by definition, it is the arithmetic average of all the individual numbers or cases in the distribution. So that's good to know. Why is that good to know? Well, it basically says that in order to compute it, we're going to need at least interval level data. Which means basically that we have ordinal, but there's also an assumption of equal distance among adjacent categories. So before they weren't necessarily equal, but now they are. And why is this? It's because we can have an existence of a zero. I'm just going to put 0 so we don't confuse anybody. But it doesn't mean that we will actually have a 0. It just means that, there could be a 0. But it's different than the median. Because remember, the mean, as long as there's no extreme scores, then the mean takes all of the data into consideration. But right there, that's one of its limitations. It's highly affected by the extreme scores. For example, when we mentioned income. Now, there are different formulas to calculate this. We can use group data or ungrouped data. But since we already kind of grouped ours in a frequency distribution, we're just going to go ahead and use a calculation for group data. And the way we write this, so here's a formula, and we just say x bar, which is the average. And we say it's equal to the sum of f of x, so the frequencies, times that age, so f of x, over n, which is the population. And this works for a population. But we need to calculate this. So let's quickly calculate this. Bring back our chart. Remember what we had? Do you guys remember? For the age, which is also x, what did we have? We had 16, right? 18, 19, 20, 21, 22, 24, 25, 52, and 68. Now, remember, we had our frequency, so how many times did it occur? 1, 2, 19 was 2, 20 was 3, 21 was 2, 22 was 2, and the rest just occurred once. Okay, but now we have to do this f of x. So 16 times 1, 16. 18 times 2, 36. 19 times 2, 38. 20 times 3, 60. 21 times 2, 42. 22 times 2, 44. And then the rest are really easy. 24 times 1 is 24, 25, 52, and 68. But then we total these up. So we're going to add all these up, which we can write like this. And what do we get? We get 405. But to get the average, okay, we have to take that and divide it by the total number of the population. Remember that was 16. And what number do we get? We should get 25.3125. Okay, So about 25.3, and that's years. So we're going to say this for this data, the average is 25.3 years. It's interesting for our class. Now remember, if we draw our distribution just on a straight line, okay, remember we said, use some different colors here. If we said that this age was what, 16? So we had 16 here, 68 here. Remember our median, it's right smack in the middle. What was our median? We said it was 20.5. And we said our mode was about 20. And what do we just come up with? Our average, if we look at, it's probably about here, 25.3. So just looking at all of these, just to quickly show. So this was the mode, this was the median, and this was the mean. Just do that. So what do you think? What is the best representation of all our data? Hard to say. Here's the rule, and this is a pretty good rule. And it's basically that whenever possible, we want to use the highest order. So we want to use the highest order possible. Now, what this means is usually it's going to be the median. So usually the median under measures of central tendency is our best bet. But look where our median is here. This is where our median is. It doesn't really accurately take in all the data. It does, but it's highly skewed by that 68 and that 52 we had out here. So we kind of want to sort of just move it and say, well, what is our middle number? I mean, we could use all these, but the median is really the best measure. I'm sorry, it's usually the mean. And this is our mean. But in this case, it's the median because we actually have highly skewed data from the extreme scores. Forget my handwriting, but and that there you have it. Those are measures of central tendency. And next we'll just talk about measures of dispersion. But there you have it for now, measures of central tendency.